Good morning. I'm going to show you guys an example of how to solve a problem using Newton's universal law of gravitation in that equation. So let's read our problem first. Determine the radius of separation in meters for Earth, and it gives the mass, and the Moon, and it gives the mass, if they're, oh, I forgot kilograms. Oh, that's funny. I'll fix that. If their gravitational attraction is 1.98 times 10 to the 20th newtons. Okay, so all we're going to do is, let's write out our steps actually first. So let's do steps. Ooh, that's too hard to read. Let's do white. Yeah, let's do our steps. Let's determine our equation. There's only one. Let's do algebra to solve for what we need to, so we can get the radius by itself in this problem, whatever we need to solve for by itself. And then let's plug in values. And that's it. That's what we're going to do. Pretty simple, as long as you can plug it into the calculator correctly, which, tricky, okay, admittedly tricky. So our equation for this one is Fg is equal to G m1 m2 over r squared, but we're looking for their radius, meters. So let's get r by itself. So I'm going to multiply by r squared on both sides. That'll cancel. And then that'll be r squared Fg is equal to G m1 m2. I want to divide by Fg on both sides. There we go. And now I'm left with r squared, but I need to get r by itself, not r squared. So I'm going to do a square root of both sides, and that's going to cancel the squared. So I'm going to be left with r is equal to the square root of G m1 m2 over Fg. All right. We've already got our values. Let's plug them in, and that's going to be 6.67 times 10 to the negative 11th. That's our G value, times the mass of Earth, 5.98 times 10 to the 24th, times the mass of the Moon, which is 7.35 times 10 to the 22nd kilograms. And we'll divide it by the force of attraction, which is 1.98 times 10 to the 20th power. And that's it. We'll plug that in, and we're going to get a value of 384.7 times 10 to the 6th meters. So 10 to the 6th, that means a million. So this is going to be the same thing as 384.7 million meters. And the reason I bring that up, you can leave your values as times 10 to the 6th, or you could put megameters, which feels wrong. But the reason I bring that up is because these values are real. I looked up the value for the mass of Earth and the mass of the Moon. However, I rounded to the 100th place, so the values aren't going to exactly match up. But if I go to Google and I say, what's the distance to Earth from the Moon in meters, it says 384.4 million meters. We're using real values in this practice. You can double check yourself. You still have to do all the work. You still have to show everything, but you can check yourself. Now you'll notice this is 0.4 and ours is 0.7, but that's because I rounded. All right. Hopefully this has been helpful. Good luck.